Inside this factory, toxic waste and fire are controlled to build new power sources. Here, discarded batteries are reborn through danger, pressure, and industrial precision. The process begins where discarded UPS batteries are collected from scrap markets. Even discarded batteries remain dangerous because acid and lead still exist. Heavy steel cages are used to safely contain hazardous battery waste. Workers secure loads carefully before transport begins. Once loaded, hazardous material moves toward controlled recycling facilities. Transport links scrap markets directly to large-scale recycling plants. The factory marks the shift from waste handling to industrial processing. Machines replace human hands at intake to manage extreme weight. Conveyors move hazardous batteries toward the first stage of processing. Every movement is monitored because errors here can be dangerous. Staging zones prepare dangerous materials for crushing and separation. From above, the flow reveals how waste enters controlled recycling systems. From above, the flow reveals how waste enters controlled recycling systems.
Warning systems signal that heavy processing is about to begin.
Protective equipment is mandatory before hazardous processing continues. Crushing systems power up, marking the start of industrial recycling. Speed increases as the system prepares for continuous operation. Final checks confirm readiness before core processing begins. Raw material flow now feeds directly into the core recycling process. Crushing begins as entire batteries are broken down into reusable industrial components. Separated fragments move forward as machines begin sorting valuable materials. Extreme heat melts recovered lead, transforming hazardous waste into usable metal. Hydraulic systems shape molten lead into standardized blocks for reuse. Plastic casings are cleaned thoroughly before entering new production cycles. Recovered materials stabilize here before becoming part of new battery manufacturing. Once solidified, lead blocks move forward for inspection and controlled handling. Plastic fragments are separated precisely, preparing them for reuse in new casings. Flow rates are monitored continuously to prevent overloads and system failures. Remaining residues are removed carefully to keep the system stable and safe. Multiple material streams operate together, each following a controlled industrial path. Core recycling completes as refined materials advance toward new battery production. Robotic handling moves refined lead safely, reducing human exposure to heavy materials. Air cooling stabilizes plastic fragments before they enter molding operations. Separated materials now follow different paths towards specialized manufacturing lines. Pressed lead blocks exit the system, ready for reuse in new battery production.
This entire section runs continuously, balancing speed, danger, and precision. Recovered lead is poured into molds, forming the core plates of new batteries. Newly formed plates cool gradually to achieve strength and durability. Plates are assembled carefully into cell structures for energy storage.
Recycled plastic is reshaped into new battery casings under high pressure. Internal components are inserted precisely to maintain electrical balance.
Sealing machines lock casings permanently, preventing leaks and failures.
Pressure testing confirms each battery can withstand real operational stress.
Synchronized lines ensure consistent output across the entire factory.
Emergency systems remain ready because speed leaves no room for mistakes.
Assembly completes as finished batteries move toward final inspection.
If you value real industrial stories, subscribe and enable notifications to stay connected.
You and we are like a family here. Share this story and continue this journey with us. This is how waste transforms into power through discipline and industrial control.